well, slight change in direction, a bit more into some quantitative data stuff now. So I'm from Loughborough University School of Civil and Building Engineering. I'm going to tell you about some work I did on a project finished about 4 years ago. It was a climate change adaptation project, and we were looking at retrofits on houses. And there was a lot of data to communicate, and so we needed to find a way to get this across, particularly to our stakeholders. People mentioned earlier about communicating to non-expert audiences, so we had a range of people. We needed to find a way of getting this huge amount of data into a form that people could use it as a toolkit and look at retrofit options for houses. So I'll just tell you very briefly a little bit about the background to the project so you see the problem we were looking at. It was called Community Resilience to Extreme Weather, and I started off really just looking at the effect of some adaptations to how you could do to houses to prevent overheating or reduce overheating during a heat wave period. But as we went along on the project, we thought, well, we don't just look at the impact of the single measures. That would be reasonably simple. We want to look at the effect of combined measures. So suddenly you've got, for example, putting some insulation on a wall and putting some shading overhang shading to reduce solar gains. And then not only the effect on summer overheating, but it's then important to start thinking about what you might do to the annual heating energy use for the house. If you do some of these measures, will that increase or decrease your heating energy use? And then also our stakeholders wanted to know how much this might cost, so then cost was coming into it as well. So suddenly a lot of things to try and communicate in one go. So these are the sorts of things we looked at, different insulation measures, different ways of reducing solar gains through the windows, blinds and curtains and shutters, solar reflective coatings, and a couple of behavioural things about window opening. So, as I say, the first results in the first few months of the project, pretty simple. We'd run this x-axis here is just the measure of the overheating during the heat wave period. So you've got the base case house there, it's overheating that much. And this is the effect of doing the different individual measures. So putting some loft insulation in had a very little effect on the overheating, but external shutters on the windows or solar reflective coating on the walls for this particular house type, solid wall house, had the biggest effect. So that was quite simple. Then this parameter tree just sort of shows the sort of things we then wanted to consider. So if you take just one of the house types, a flat with one of the occupancy profiles that we're looking at, and then ran it for 4 different orientations of the house, of the flat, and then you looked at each of the measures in turn with or without other measures, that adds up, over all the house types we're looking at, to over 8,000 results for one house type. And if you look at all of the house types that we're looking at, into 180,000. So suddenly you can see the bar charts would be impossible. Plus, there was the extra information we wanted to get across about heating energy use and cost. So, went to a scatter plot approach. So this is, now we've got on the x-axis the cost, the y-axis has the overheating, and so you can see there's the base case where we've done nothing to it. It's overheating quite badly, but it's cost nothing at this stage. So then, these are the individual adaptation measures. So that's the external shutters on the windows, brought the overheating down, cost about £3,000. In this case, internal wall insulation actually increased, well, all the wall insulation, but internal was the worst, actually increased the overheating and cost about £4,000. So then you put all of the dots on for that particular case. So there's all your possible results for all your different measures and combinations of measures. And then we looked at colour coding for representing the effect on the heating energy use. So the larger the shape of the marker, the size of the marker, the greater the effect. And blue was heating energy reduction, red meant it was increased. So there's a lot of information there. But then, and this was all done in Excel, but how do you find out what that point is there, or that one there, or that one there? And it was very tedious interrogating these results. So that's where this bit of software came in very handy. It's free, it's called HighChart. And I should be able to actually go to the website rather than use these. These things. So if you go to highcharts.com, and if you go to some of the demos, you can sort of look at. It just takes a second to load up the demos. So you can look down all the different sorts of charts, and if you look at get down to the scatter and bubble charts, which are the ones I was interested in, and you can see that this, I spotted this and thought this had great potential for what we were doing. It's got that information, the colour coding, it's got the 2 axes for information, and it has this thing called tooltips. So as you hover over, it then tells you some information about that measure or that data point. And they've improved it since I used it. They've now got this thing called edit in JS Fiddle. What we had to do before was I took the example. You can download their templates, and then you can edit them in an HTML editor, which isn't as scary as it sounds, because I know nothing about HTML, or I know a little bit now, but I knew virtually nothing then. And all I did was I took their template, and then I just went down to the bits where I could see that there was something in quotes that was a title, and changed it for my title, and then dropped the data. So if you go to this edit in JS Fiddle, it'll open it up in so it looks all scary there. But as you go down, so you can just change where it says RGB. That would give you the colour of something. So you could change that and change your colours. And then you get down to the data section. And all I did was it was a bit of work to put it into Excel. And then do some filtering to produce my results into that same format, and then drop those in on the template. I mean, it is a little bit of work, but I can show you. So that was one of the Excel sheets. So I managed to get all my measures strung so that the text for the measures was then strung together within the name, and then the columns with the X and Y coordinates, and then I banded them into their effects on heating energy use, so that then they dropped into the banded sections in the HighCharts template. So the best way now is to actually show you the toolkit and how it works. So this, when you go to the homepage of the toolkit, anyone's interested in having a look at it, and give you the web address. It's on the Crew website, and you can get to it through my profile at Loughborough University as well. So on the home page, it tells you a bit about the house types that there's an introduction about the house types we looked at, and then there's some other tabs just to give you information about there's some information on the papers behind it, the methodology, about the overheating and what degree hours mean and things like that. There's a bit of information on the floor plan so people could see how the layout of the houses was, work out the orientations, and then the 4 house types. So if we pick one of them and pick a top floor flat, so you can see the bar charts with the single measures in the middle, and that you can choose different rooms, and you can change the orientation and change the occupancy profile, and it will reconfigure and tell you the effect of the single measures. But then the more interesting bit is the scatter charts. So You see that looks pretty much like the scatter chart before, but now we've got the pop-up box. So as you look at this, and you, as a designer or a housing association, it was particularly used by housing associations in London that were partners on this project, they could look at measures that they might consider doing. They could say, well, our budget for refurbishing these flats is £10,000 per flat, so you start looking around this area. And what you can even do is then say, well, we're only really interested in things that really reduce the heating energy use by over 40%. So you filter out the things you're not interested in, and then you look down, effectively it's a Pareto front, so you look down and you look at the measures and you actually see actually there's a bit of a hole there at 10,000. So, you know, for sort of 7,000, you can do that set of measures. But the good thing about this is you could just filter this to the best measures and say, well, we're just interested in the very best at any price point. But you might miss something that's more appropriate for that particular house. So you can explore other options around about. So that's a sort of brief introduction to use of pie charts. And any questions? Or?